So you guys built a data acquisition system to get the head-related transfer function to put it in the MATLAB for analysis and then resynthesize through a microcontroller. Tell me about the project.
So we started out by basically taking a set of 3 microphones, 2 of which would go into the test subject's ears.
So these are little foam inserts with microphones on them.
Yeah, and then we also had another reference microphone that was taped to the chest, basically.
Okay.
And then we had them sit on a rotating stool that, and then we would play basically a chirp sound from a fixed speaker, and then have
the subject rotate,
yeah,
and look at the recording at each earphone for each different angle. This is a preamp board here.
Yeah. And
then what's this?
So the preamp board goes here, which is what the microcontroller is hooked up to. So we have an MSP430 launchpad development board, so kind of sitting underneath.
Tucked under the.
Yeah.
Okay.
So we're using the internal ADCs for that to collect the data, and that stores it in a set of 3 SRAM chips, and then from that we would transfer that data back onto a computer where we could do analysis in MATLAB.
Okay, and you got data from 2 different subjects under 4 different conditions, with hair tied back and down.
Yep.
And what were the other 2 conditions?
Oh, with and without glasses.
With and without glasses. Okay. And then once you had it, once you got it into MATLAB, you looked for symmetry in the waveform, for time delay, for filter characteristics, extracted parameters.
Right. Yeah, we looked at variations in amplitude versus angle, the time difference between the 2 ears versus angle, and also plotted spectrograms, basically, or power spectral density versus angle, so we could just get kind of a visual estimate of what the general frequency characteristics are versus what the angle of your head is. So,
okay. Yeah. And then you took the simplified model, put it back on the MSP, and then synthesized from there. Did you try the experiment of your own head versus the other person's head model for accuracy?
So we basically, the model we had was essentially the average of the 2.
I see. So you made kind of the mean. Okay.
Yeah.
Would be interesting to do the other thing though too, right? Is maybe to even caricature it. So you take the 2, the male and the female head-related transfer functions, push them in the directions away from where they're most different, so to make caricatures of the 2, and then see how it affects each of the listeners. But it worked. But everybody felt like they could get the direction of the sound from the recordings?
Yeah.
Okay. And it worked for me. And even when it was behind me, which is impressive, because behind is a hard direction to get.
Yeah.
And then you're playing back through the earphones here, and unfortunately that doesn't go well onto video, so we can't really demo that. And I suppose you could put a spatialized sound up on the website.
Yeah, that's true.
Why don't you do that? Play it back into a computer, and then you can exhort people to put on the earphones and listen to it.
Yeah, definitely.
Okay, so this broke down into 3 different projects, you said.
Essentially.
And so there's the acquisition part, which was experimental, and then the analysis part, which took quite a while.
And then the synthesis.
And then the synthesis, any one of which could have been a full project, more or less. Impressive. And it works. Anything else you'd like to say about it?
I guess you were talking a little bit about the amplifier.
Yeah, so we also, so for doing playing back sound, we have our input coming from just a normal
Sure.
audio jack going into a board here, which basically takes the stereo sound source and converts it to mono and amplifies it. Then that goes back to the MSP430 where it gets sampled and processed. Then there are DACs on this board which send it to a headphone amplifier we designed as well.
Okay, so you want to destroy all of the stereo cues from the original music because you're putting your own back in.
Yeah,
Exactly.
Got it. Okay, that's why you're doing the conversion to mono.
yeah.
Okay, very good. Thank you.